Water is fundamental to human development, from drinking water and sanitation to agriculture and more. You listen to Water Stories, a podcast series where you will learn everything about securing water, energy, and food security for all of us. In water management, we have to think about all those involved, such as communities, scientists, governments, technology, and of course, the ecosystems that play an essential role on a small or large scale. In the first episode of this second season, we discussed the Water Beyond Boundaries initiative and its main goals. And one of the pillars of the Water Beyond Boundaries initiative is natural ecosystems. In this episode, we will talk with our guests about protecting those parts of our natural ecosystems, like the Chinook salmon and other species, of course, and connection with Water Beyond Boundaries. Once again, my co-host is Vishal Mehta, an environmental scientist with more than 15 years of experience in water resources research at the Stockholm Environment Institute. Vishal, how are you? It's a pleasure to have you today as a co-host again. How are you?
I'm good, JC. Thanks. It's good to be doing this again.
Vishal, very interesting episode about natural ecosystems and how it's related with Water Beyond Boundaries initiative from the Stockholm Environment Institute, right?
Yes, definitely. And for me, it's a great pleasure to invite our speaker today, Max Stevenson. He's also a friend of mine and somebody I've worked with for, I think, 10 or 12 years. I think the context for today's episode is also really interesting. As you know, the Southwest US has been in a deep drought. The last 22 years rank as the driest period since at least the year 800 AD, so about 1200 years. And the second context is that we are talking to Max. He's the stream keeper of Putah Creek. And Putah Creek runs right through town here in Davis, California. And so he will be with us to talk about the history of Putah Creek and shine a light on positive message, which I think we really need, about the restoration effort, the role of the stream keeper, and the history of this place, which is really fascinating given the history of water development and drought in California.
Max, nice to meet you, and we are so happy to have you today in this third episode. How are you?
Oh, I'm good. Thanks, JC.
No, it's a pleasure. Max, when I was preparing for this conversation, I found a term, and perhaps our audience would like to learn more about it. The term is a stream keeper. Max, what is a stream keeper?
So that's the name of my job. That's the position. I'm the stream keeper for Putah Creek. After people asking about salmon, the next most popular question is, what the heck's a stream keeper? And it's a funny responsibility. There was a lawsuit in 2000 that the environmentalists won called the Putah Creek Accord. So more water got put into the creek for fish and wildlife. But part of the lawsuit was creating this position of someone to steward restoration projects, watch over the water, and they called it a stream keeper. And so 22 years ago now, that was they hired Rich Maravich. He retired at the beginning of the year, and I got hired to be the new stream keeper. It's kind of like being in charge of things, but not really having any authority. You have to keep the water in place and help the fish, but we don't. I work for the water district, the Solano County Water Agency. We don't own any of the land. It's mostly private. Some is owned by the university. So it's all kind of soft, convincing. You try to, help people understand and join the community to share the creek. The creek's got, like you were saying, there's so many demands on water in the Southwest, the U.S.
Interesting. I read, probably you guys know more than me, that it's a significant stream in Northern California, right?
Well, in terms of flow, it's very small. Yeah, so, the Sacramento River, well, if you're from the East Coast and you look at the Sacramento River, sometimes you might say, oh, that's a creek, just because there's so much less water here in the West. But people, they hear I'm in water. I worked for an irrigation district for almost 20 years, and people always ask about the water supply, and they want to know about the snowpack, because the snowpack is like a big reservoir in the winter, and then as it melts in the spring, we can manage that. But Putah Creek doesn't have a snowpack. It's on the Coast Range. So up in Lake Tahoe and the ski resorts, I'm a big skier, so I love talking about the snow. But the water that we manage here, Putah Creek, it's on the Coast Range and opposite, the other side of the Central Valley, lower elevations, basically no snow, 100% rain-fed system. But in 1957, the Bureau of Reclamation, the federal government, they constructed a very large dam on Putah Creek and formed a reservoir called Lake Berryessa. That is one of the larger reservoirs in the state. That's true. But the creek itself, before 1957, it used to go dry. It would go dry many years, as creeks do in the arid West, and but not every year, but some years. And there really weren't much salmon. The studies that the feds did in the 1940s and 50s before they made the dam, they found no evidence for a strong salmon run. Occasionally salmon would show up, maybe a dozen. Some years none would show up. Two issues. One, the creek went dry, so that's not good for a salmon run. But also the temperature of the water was a little bit high, so sometimes it was cool enough. But cooler water has greater ability to carry oxygen, so dissolved oxygen. Salmon love oxygen, and all organisms do. But it was temperatures were too high, and it would go dry. So there was no regular run of salmon.
Thank you, Max. Well, it's understandable this part of the world, is facing right now high temperatures. Vishal.
Yeah. So Max, I was just wondering if you could tell us what Putah Creek was like before 2000 and before the agreement, and then since then, in the past 2 decades, what kinds of restoration activities have gone on, and how you feel about where it's leading up to and the positive things that have come out of it.
That's a great question, Vishal. But starting in 1957, when the dam was placed, there was now a reservoir of water to draw upon. And so by 1970 or so, the management of the dam would let water out continually. So it didn't dry up anymore. This was a big change in what was there historically. And then, a certain amount of water was let out every month, even if it was wet or dry. And riparian ecosystem, the trees started growing. People started enjoying being able to go to the creek in the middle of the summer, and it never went dry. But in 1991, there was historic drought in California, which, if you're old enough, you'll remember that. And the creek went dry, and people weren't used to that. They were used to this established perennial stream that was always wet. It had been 30, 40 years of having water there all the time. And so the environmentalists, the Putah Creek Council was formed, and they sued Solano County Water Agency, my employer, to put more water into the creek so that it wouldn't go dry. And on top of that, they wanted salmon. Even though there had never been salmon before, they said, well, you've got this big dam with a very deep reservoir. There's a lot of cold water at the bottom of the dam that's coming out. And if you've ever swum in the water out there, it's freezing. So that's like a surrogate snowpack. Even though it's completely man-made, the Putah Creek Council said, well, we want to have a salmon run, and we have the cold water. And if we, make the gravel spawning grounds and do the other restoration practices, maybe we can do it. So that was in 2000. So Rich Maravich, the old streamkeeper, he got a ton of grant money and probably more than $15 million to restore the creek. The creek had been heavily modified, channelized, mined for gravel, sewage pits. So they cleared it every year of all the trees for flood control for a 30-year period, kind of a mess ecologically. And so what Rich, the previous streamkeeper, has been doing is taking these grants, putting the channel into a more natural form, sinuous, curving, smaller, faster, colder water, no big ponds for, the sun to heat it up and for aquatic weeds to grow. It would be more like a natural stream. And lo and behold, starting about 2014, the salmon started showing up. Almost 500 salmon showed up in 2014. And there had never been that many salmon before. It was a very big surprise, and people started getting excited. And by 2016, almost 2,000 salmon were showing up. The city of Winters, which is right on the creek near the dam, the town that built the dam, they have the Winters Salmon Festival. So they have a party down by the creek and music and beer and all there, and people in fish costumes and kids doing fish art. And it's very exciting. We as humans, or as a community of humans, we can create cities, we can create factories, we can create huge areas of farmland producing food. But if we want, we can also create habitat for wild things that wasn't necessarily there before. I don't want to be playing God or anything, but we can manage to certain goals. And if we manage to wanting to have salmon run, we make it and they will come. I mean, that's what happened. They showed up. So now we've got an established run in Putah Creek. Putah Creek's about 26 miles long till it hits what's called the tow drain down over by West Sacramento. And all the spawning happens in the upper reaches because that's where the water's cold and that's where the gravel is. It gets kind of flat and it's more like an agricultural drainage ditch in the bottom 5-8 miles, and the water's warmer there. It's not as good for salmon, but they swim through it. The salmon come from the ocean, swim into the delta, come up the tow drain, and then come up to Putah Creek.
Thank you, Max. The truth is that this whole cycle of salmon or activity is amazing, and everything that happens around it is really, really interesting. I would like to share an audio clip of Doug Chalmers, a scientist from Stockholm Environment Institute. This audio clip is from a webinar he participated in last March hosted by California Lakes, where he shared his view on fish habitat and is related with this topic. Afterwards, I will let you know your opinion, Max, or maybe Vishal can add some insights as well.
If we think about the context of two of the species, one of them being steelhead trout, it's a threatened ESA species, and we're down to less than 10% of the historical population. And part of this, one window right within Santa Clara County where this case study is that between the three stream system, 21 to 54% of the habitat is blocked by urbanization and dams. So habitat's blocked, fishing, urbanization, temperature effects from climate change. So threatened and really dwindling species numbers. Similar story for the fall run Chinook. It's a species of concern, and it really used to be one of the most abundant fish runs in the whole state of California. What I find alarming was that even by the early 1900s, it was already down to less than 10% of its historical population. And surely it's just a fraction of what it was back 100 years ago.
Max, Vishal, what do you think about what Doug Chalmers mentioned?
So Vishal, should I take this first?
Yeah, go ahead and take it. Yeah.
The backdrop for all this success on Putah Creek is the salmon are disappearing from California. It's been a long-term process. In Alaska, they're still super abundant. It's fun to go up there and fish and experience the resource. But yeah, here in California, they've been dropping. The story is that we made these dams, all the big dams on basically every major river, and so let's go over the salmon life cycle a little bit. So salmon are anadromous. They are born up in the freshwater creeks, spawn, their eggs are laid in gravel, and then in a few weeks they hatch out and eat food in the local area up in the streams. But when they get 3 or 4 inches long, they start migrating downstream. They go all the way out to the ocean, and then they spend a couple years out into the ocean, growing from 3 inches long to 3 feet long, a big salmon that you might imagine. And then they come back one final time. They come from the salt water, go into the freshwater, swim all the way back up to where they were born, lay their eggs again, and then they die. But that's the life cycle of the salmon. These dams, all these, wonderful hydropower resources, flood control, irrigation, water for cities, they weren't really thinking about the fish when they made these. And there's no fish ladders generally. I mean, there's no way for the salmon to jump over a 200-foot tall dam to spawn. The idea was that you could use, we'll just make hatcheries. So we'll make a little fish factory below the dam. We'll raise up the fish in big tanks, or the eggs, we'll hatch them in big tanks, and then we'll release them, and that'll keep the fish. Well, those fish aren't really doing what we thought they would. They're not the same ecologically in the system. They're different genetics, and then the numbers just aren't there. There's all sorts of other things that people are trying to do below the dams and for fish passage around the dams. But below the dams, doing gravel injection, giving them a place to lay their eggs. These are huge projects with 100 dump trucks working for a month, dumping thousands or hundreds of thousands of tons of gravel into the streams to try to make these beds. But there's other parts of the life cycle of food for the little baby fish to eat. The Sacramento River has been channelized for flood control, and the surrounding floodplains have been drained for agriculture. So the salmon, the baby salmon, when they're coming down the stream, coming down Sacramento River, for example, there's not much to eat. So UC Davis researchers have been, and others have been, raising fish in little cages. So they take the 3-inch fish, a dozen of them, put them in a little cage, put them in the Sacramento River, and then put them in a flooded rice field that used to be floodplain, but is now a rice field. And then they grow them up for a month, and they measure them and see they're called floodplain fatties. The baby salmon that are in the cages in the flooded rice field grow at 3 times the rate of the little baby salmon that are out in the Sacramento River. And that's because the primary productivity, the bugs and the life that's growing in this shallow flooded rice field, only 6 inches or a foot deep, it's just way more productive. And there's more places to hide from predators for the fish. There's more food to eat. And the idea is that we can reactivate the floodplain by putting water onto these rice fields and managing it so that fish can grow on them. We've already done the same thing with birds on rice. So there's millions of acres of rice in Northern California. Gosh, in the early 1990s, they used to burn it. So you harvest the rice, there's all the stubble left, and to clear the fields, they would burn it. And in Davis, oh my gosh, I remember every fall, I'd open my door and look out the window and look up into the sky and see a multi-1,000-foot tower of black smoke coming down from the north from all the rice fields around us. And I went to the store and bought an air filter for my bedroom. But people complained about that. And so that they don't do that anymore. And what they did was put water on the fields in order to decompose or make the rice stubble, the hay basically, rot. And lo and behold, that is perfect habitat for migrating birds. By the millions, these birds are coming into these flooded rice fields for rice decomposition in the fall and eating the leftover rice, eating the bugs that are there. It's a huge success story by just changing this one practice. And it doesn't harm the farmers at all. They're still growing rice, but there's this extra benefit of having millions of birds show up. Well, we can do the same thing with baby fish. Just open it up in the right ways. I mean, there's a lot of things to figure out. It's complicated, but you can have a working landscape that provides food for people and food for birds and food for fish too, that we can eat.
Right. I mean, what's amazing about this story is how many different parts there are to it, how many people and policies and actions are involved, from very active changes in land management to water management to policies, legal actions, and the work of someone like a streamkeeper whose job is really, as I see it, Max, to kind of bring about collaboration and nudge people to do the right things, which your predecessor did for 20 years.
Thank you, Vishal. Max, when your predecessor Malkovich worked with the landowners, he co-created and he designed with them, and we know that they are essential stakeholders. How was the reaction to this new initiative or project that Malkovich presented to them, in your opinion?
So in California, there's basically 3 legs to the water stool. There's 3 user groups. It's municipal, industrial, the urban use. There's the agricultural use, and then there's the environment. So it's ag, urban, and environment. So in this lawsuit from 2000, the Putah Creek Accord, it was the environmentalists versus the urbans. So the developers of the dam were getting sued by the environmentalists. The agriculture wasn't part of the lawsuit. So there's maybe 25 pumpers, diverters of water from Putah Creek that take water out of the creek to grow food and have the habitat benefits of agriculture that we were just talking about with rice. And they were informed of the lawsuit and they thought they were getting sued. So the farmers the landowners, like you're saying, didn't participate as much. Some of them did, it's all many different people, but hundreds of landowners and only 25 or so pumpers, big pumpers for growing crops. And what we need to do now is make sure that all the users of the creek are honored and satisfied and working together. So this idea of a working landscape, you can have water flowing in a creek and use it at the end for agriculture, but the salmon can also use it before it gets pumped out, right? It's a shared resource. It can be used multiple times. And then your question with Rich, Rich, he was a visionary. He would see things different than other people. He would see them as the fish coming back and the birds coming back and the trees coming back and the farmers being able to farm and the kids being able to go down and play in the water, have access and have the native plants coming back and getting rid of weeds. Just the way he would talk about it. Myself, I was kind of enthralled by this, and I think a lot of other people were too. So he really led the way, but still the diversion of the irrigation water for agriculture down at the bottom is historic, and they have a water right. But some of the things you do to divert water is by putting in what's called a check structure, like a miniature dam. So you can just push some dirt into the creek and make a little dam, or you can have a structure with boards and a metal frame that backs up the water like a small dam. And what that does is it makes a pool or a pond that you can pump out of to irrigate your crops. Those check structures are quote, barrier to fish passage. So they block the spawning adults trying to come upstream and the baby juveniles in the spring trying to go back out to the ocean. So there's a series of these check structures that come in and go out, and there's different ones, different years, and it's just the way it's been done. It's a very common way to do things in creeks, but in streams. But in Putah Creek, there never was this salmon run before that we need fish passage. These are migrating fish, swimming hundreds of miles. It's amazing. So they need to be able to get through. So how can we continue to honor the water rights of the farmers and grow food and have the habitat benefits of ag while letting the fish go by too? We can figure this out. There's no reason we can't do it.
Oh, thank you. Great explanation, Max. Before giving Vishal the pass, I would like to add that Malkovich used an excellent management technique, which is the co-creation. Co-creation is a form of collaborative innovation. Ideas that are sharing and improved together rather than keeping, to oneself. So that, I think, was a very, very important that he, as a visionary, like you mentioned, execute, this great management technique. Vishal?
Yeah, I was also wondering, Max, if you could illuminate us about pre-colonial relationships of Native peoples in Putah Creek watershed.
Oh gosh, that's another great question. The Native peoples that lived here for thousands of years are still here. I mean, they've got a casino up on Cache Creek and work with them, and they farm too, got big farming operations and buy water and are very interested in keeping the environment productive and habitat. I'm learning about that myself. I do not know that much about how things were managed by the Native peoples before colonialization, but I do know they did a lot of work. When the whites came to California, and there's tons of historic documentation, they were amazed at the productivity that they found. The flocks of geese darkening the sky, walking across the backs of the salmon that were so thick in the streams. And this was attributed to natural bounty in the writings from that period, early 1800s, 1830s, 1840s, up until after the gold rush and the 49ers into the 1880s. And, the Native peoples are like, wait a second, we were managing this, maybe not the way you think, but, fire is in the news today quite a bit. The forest fires, they would set fires on a regular basis to keep them small and to promote the growth of certain things. For salmon, they would do the same thing. A friend of mine was telling me about a salmon ritual up at the Yurok on the coast, where the shaman, the medicine man, would have the village would be waiting for the salmon run to come so that they can smoke them and preserve them for the whole year, and that's one of their main food sources. But before they could start harvesting, and they had all kinds of mechanized things to harvest the fish and traps and nets. But before they could catch the fish, the medicine man went down and would catch the first fish, and then would go and pray over the fish, and they would have ceremonies over the fish for a couple days. It would take a couple days, and then when the ceremonies were done, then the village could start the big harvest. Well, this seems like, a ritual, but it's also a management technique for population of the fish. So for those 3 days, the fish got to go by their village and spawn up in the gravels up higher in the watershed. And so that would be the adults that would spawn for next year, so that the fish, the population would continue to be high. So it was a harvest management quota, but done through ritual and ceremony. And then other examples of, sometimes productive salmon streams get blocked when they enter the ocean by sandbars. And so the natives would go down and they would dig out the sandbar and allow the salmon to come in from the ocean to spawn. There were hundreds of thousands of people in California before the colonial period managing the resource here to be productive. I don't know the details of how that's happened, and so many things have changed with urbanization. But I think there's a lot to learn, and I have reached out to the local tribe, and hopefully we'll start talking soon. And maybe they've got some elders or some knowledge of things we can do to help the fish and ourselves, the whole system.
Thank you, Max. Everything behind this activity is very, very interesting, fascinating, I would say. I am learning, a lot. Thank you. Vishal, I have a question for you. In your opinion, how does this related to the Stockholm Environment Institute Water Beyond Boundaries initiative?
Well, it's a fantastic example of water beyond boundaries because, as you can see, salmon need a lot of space. Their life cycle is such that they need to go to the ocean, they need to come back to specific reaches of specific rivers high in the mountains. So there you go. They've broken the saltwater, freshwater interface right there, going from sea to land. And then we, as people do, have blocked those patches through dams and so on, which Max so eloquently described. And now we can just as eloquently and bring them back through management of a different kind. And I think that's why I wanted us to talk with Max. It's like to showcase some of these very positive outcomes that can come, but just the level of effort and complexity that's involved in doing the same. And for me, it's also very personal in the sense that both Max and I live here in Davis, and Putah Creek runs right through Davis. And especially in the first year of the pandemic, me and my family spent many days going hiking and enjoying the waters in the open, as did much of the Davis community along the Putah Creek in the reserves. So, and the streamkeeper has had an important part to play in that. So I think it's especially meaningful to us who live here, and want to thank Max and everybody else who has contributed to that.
Oh, thank you. Thank you. That's great example. Thank you, Vishal, for sharing with us your thoughts and your explanation about how the salmon, Chinook, and the Putah Creek is related with Water Beyond Boundaries initiative. Before wrapping up, Max, is there anything that you would like to add to this conversation?
Oh, yeah. The Putah Creek is a really interesting example of what we can do, managing towards goals of habitat and irrigation and recreation. It's multi-benefit is the buzzword these days, but it's really true. So can I talk about the history of Putah Creek a little bit more from a flood control perspective? This big dam was built for supply and flood control. Before the dam was built, huge flood flows would come down, 60,000 cubic feet per second. I know that doesn't mean anything to the listeners, but a lot of water would come down, and it would partially flood out the towns of Winters and Davis. But since the dam has been built, the maximum flows ever seen in the creek are now less than 20,000. So it's a 2/3 reduction in the flows. So those big flows used to kind of clean the creek. They would blast out all the dead trees, vegetation would get moved along. And in fact, the bed load, which is when creeks and streams are flowing, in flood, bottom 5 or 10% on the bed of the stream is active, and tons and tons, millions of tons of gravel and sand and mud is coming down the creek also. So you got the water on the top 90%, bottom 10% is this bed. And then once the floods go away, the waters have receded, you've got a new deposition of gravel, sand, the channel morphology, the shape of the channel has been changed. It's active. It's an active channel. Well, that doesn't happen anymore because we don't have these large flows. And that's what's changed the system. So pre-dam, you'd have these large flows and the channel would migrate. It would move 3 miles in one direction, 3 miles in another direction. But now with cities, roads, farms, everything has encroached upon the channel to make it smaller and to make it more permanent. And then the dam itself, reducing the flows, helped with that process too. So from an active migrating channel with millions of tons of sediment and gravel coming down to basically a static or a non-active channel that doesn't have a chance to move around or have new gravel placed down by the flood flows. But what it did, it allowed trees to grow, more riparian habitat. Shading is important. The large trees shading the water to keep the temperatures cool for the dissolved oxygen for the fish. It's been this process that's dramatically changed the very nature of the creek. We're doing that everywhere. I mean, you go to downtown San Francisco, it's not like the 1600s anymore, right? It's all urbanized. The creeks are the same. But, what do we want out of these creeks? What do we want about the landscapes that we have? Do we want them to be static and sterile? No. Do we want them to be static and living? Do we want them to be productive? I mean, we got to grow food and we got to have places to connect with nature and provide. And it's not a zero-sum game. We can have the working landscapes. We can have maybe not all the uses because there's not enough water, but we can share a lot of it and multiply the benefits manyfold.
Thank you, Max, for sharing your thoughts with our audience. Vishal.
Well, I think that's all we have time for this time. But I think, Max, you've teed up a few thoughts on who else we could bring on to talk about this. And I want to thank you, Max, for joining us today. And it was a really nice discussion. Thank you.
Thank you, Vishal. Max, I would like to say thank you for your time. It was a pleasure to have this conversation with you.
Thanks, JC. Thanks so much for inviting me. This has been awesome.
Thank you so much. For more information, you can contact our guest, Max Stevenson, through the Solano County Water Agency website, scwa2.com, or directly to his email, mstevenson@scwa2.com. Thank you so much, everyone. And don't forget to follow us on Spotify, Google Podcasts, Apple Podcasts, Amazon Music, Alexa, and stay tuned for our next episode.